Hello my dear creations. Today we will start a new topic of Electrostatics-III, that is electric potential. What is electric potential? First we will recall there will be a source charge, and for a source charge there should be electric field around it. Just to remember, in case of a source charge there is a field is there. In previous classes we have discussed the electric field intensity. Similarly here it is a source charge, let it is its electric field of infinite range, that means it is a high range. Here we have to define two terms, that is one is electric potential energy and another one we have to define, that is electric potential. Just to see the diagram first, this is your source charge. Source charge may be positive, may be negative. Here I have taken the source charge is positive. And this boundary represents the electric field of that source charge. Now we have desired a point P. We choose a point P inside the electric field. Our first part is we have to discuss what is electric potential energy. Electric potential energy means, to your desired point P, first you take a test charge. Let it is a test charge plus Q. First you keep this test charge at infinite, that means very far distance, and within the electric field. Then what happens? You bring this test charge to your chosen point in any arbitrary path. First you think, when your charge moves in the field, definitely force is acting on your charge. In previous classes we know that if any charge body is kept in the electric field, there must be electrostatic force acting on it. Again you are moving your test charge from this point to this point. That means you have to do some work. What amount of work you have done, that represents the electrical potential energy at this point. So by which language you will define this electric potential energy? So electric potential is some amount of work done. For which purpose? That means this work done is used to bring a test charge from infinite to the desired point. So this is the definition of electric potential energy. Electric potential energy at any point inside the electric field may be defined as the amount of work required for bringing a positive charge from infinite to the desired point. This is your electric potential energy. Electric potential means some amount of work. Now you come, what is electric potential? Let for Q amount of charge, work is W. Then for a unit amount of charge, work will be W by Q. This represents electric potential. So electric potential energy means total charge required to bringing a charged body, and electric potential is also amount of work required for bringing a unit positive charge. So this is the only difference, that if it will be unit is joule, its unit will be joule per coulomb. So formula, electric potential energy is your W, and electric potential is amount of work done per unit charge, or you may write electric potential energy divided by unit charge by small q. Both represent amount of work, that means both are scalar quantity. Now we will discuss its unit and dimension. First we will recall potential energy, then we will discuss electric potential. Potential energy means some amount of work, that means its SI unit is joule and CGS unit is erg. In 11th class you know that 1 joule is equal to 10 to the power 7 erg. What will be its dimension? It is same as work or energy, that means M1 L2 T to the power minus 2. Now you will come to electric potential. How your unit is defined? Formula is W by Q. For W we have taken the unit joule, for Q we have taken the unit Coulomb. This is the SI unit. According to scientist name, it is named as volt, or a symbol it is represented as capital V. So the SI unit of electric potential is volt, that means 1 volt is equal to 1 joule by 1 coulomb. Similarly in electrostatic unit, unit is start volt. Start volt represents work divided by start coulomb. This is SI unit and this is electrostatic unit. Now we have to establish the relation between them. First you recall 1 volt means 1 joule by 1 coulomb. 1 joule represents 10 to the power 7 arc and 1 coulomb represents 3 into 10 to the power 9 start coulomb. If you will manipulate or you can solve it, then it will be 1 by 300 start volt. That means 1 volt is equal to 1 by 300 start volt, or you can say 1 start volt is equal to 300 volt. You just remark here 1 start volt is greater than 1 volt. That's why I have written here 1 start volt greater than 1 volt. But our misconcept always says that volt should be greater than start volt, but that is not true. That means in anywhere SI or CGS, which one will be greater, which one will be smaller, depends upon its formula. Just to remember, here also electrostatic unit is greater than its SI unit. In usual cases, SI unit is greater than electrostatic unit or CGS unit, but here CGS or electrostatic unit is greater than SI unit. So you should not be confused. 1 volt is equal to 300 start volt. That is wrong. But instead 1 start volt is equal to 300 volt. So we have discussed the formula of electric potential energy that represent W, and electric potential represent work per unit charge. This is the formula difference is there, and both are scalar quantity, and its SI unit is joule and its SI unit is volt, and its electrostatic unit start volt, and 1 start volt is equal to 300 volt. So now we clear what is electric potential and electric potential energy. Now we will discuss what is electric potential difference. Just to see, this is the source charge, this represent electric field. There are 2 points we have given A and B. Let electric potential at the point A is V2 and electric potential at the point B is V1. Now we move a charged body from this point to this point. So we can define the potential difference. What is the physical significance of potential difference? Here, the potential difference represents the amount of work required for moving a charged body per unit charged body from point A to point B. This is the potential difference. So in general cases, how can you define the potential difference between any points in the electric field? So you can define the electric potential difference at any 2 points is defined as amount of work required per unit charge. When you define electric potential, you should tell the language work per unit charge. If you define electric potential energy, only you state amount of work. So what is electric potential difference? So you will say the amount of work required per unit charge from one point to another point. Let the potential difference between A and B is dV, and the amount of work is dW. As we know that V is equal to W by Q, similarly dV is equal to dW by Q. Then by using this formula, let's define a new term, that is electron volt. Electron volt, just to see the symbol, E means electron, V means volt. That means one electron charge moves from one point to another point of a potential difference 1 volt. That means electron volt is a unit of energy. First of thing, it is a unit of energy, not potential. Electron volt is a unit of electrical energy, or you may call it energy, simple energy. How can you define it? So you see the diagram. If this point is 50 volt and this point is 49 volt, so difference is 1 volt. How much? 1 volt. If an electron moves from this point to this point or this point to this point, some amount of work will be done. That work is known as, if electron moves, then that amount of work is 1 electron volt. So 1 electron volt in a language you can define, it is defined as the amount of work required to move an electron. Particularly you have to move an electron from one point to another point of a potential difference in the given electric field. That means this is the electric field given to you if an electron moves from this point to this point of a potential difference 1 volt, then that amount of work is known as electron volt. So electron volt is a unit of work or energy. Now how can you calculate electron volt? From your data, the potential difference is 1 volt. So you write dV is equal to 1 volt. And you can also redefine 1 volt means 1 joule by 1 coulomb. Then what is the amount of charge you are moving? Now you are moving an electron. That means charge of an electron is Q. That is 1.6 into 10 to the power minus 19 coulomb. What amount of work done you define? Now that amount of work done is 1 electron volt. So from the formula dV is equal to dW by Q, we have taken that dW is equal to Q dV. Put the value dW is 1 electron volt here. Q value is 1.6 into 10 to the power minus 19 coulomb, and 1 volt dV is 1 volt, that means 1 joule per coulomb. Coulomb cancelled, so 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. If 1 joule is asked how much electron volt, so you can write 1 by 1.6 into 10 to the power minus 19 electron volt. That is the simple calculation, that is represent 6.25 into 10 to the power 18 electron volt. So 1 joule is equal to 6.25 into 10 to the power 18 electron volt. So this is the relation between electron volt and joule, and this is the relation between 1 joule and 1 electron volt. Now we have to go a long derivation of electric potential due to single isolated point charge. In previous classes, we have also derived the electric field intensity due to single isolated point charge. Similarly, here also we have to define the electric potential due to single isolated point charge. Single means only one. Isolated means there is no one is there. And the point charge that you know already. So first you draw the diagram, that is very important. This is your source charge. First I call you source charge, may be positive, may be negative. Here I have taken plus Q. If you want, you can change this. You can also take minus Q, no problem. So here we have taken plus Q, and its coordinate is origin O here. And this is the electric field represent throughout the paper. And this is the desired point where we have to calculate electric potential. And the data is given, that is small r. That means source charge is given to you, and this distance r is given to you. Now by using the principle of electric potential, you have to calculate potential here. How can you calculate? What should be step? Now first you calculate the amount of work for moving a test charge from infinite to desired point. That's why I have in a diagram, I put a mark infinite here, and this is the desired point here. First initially test charge is here. Now it is moved from this point to this point. This is the final position, and this is the initial position of the test charge. On its path at arbitrary point is A here, and the distance between O and A, that means coordinate of A with respect to origin, is x. And here the desired point coordinate is small r. This x is variable. Initially its value was infinite, now final value is small r, so x is variable. What will happen to, how can you calculate? Now your aim is first you have to calculate work done, total amount of work done for bringing a test charge from this point to this point. Then second step is you have to calculate W by Q. So our first step we have to calculate work done from this point to this point. Here force is variable force, because electrostatic force decreases with increasing distance, that means it is variable force. So by integration method, we have to calculate the total amount of work done from this point to this point. First we calculate the work done for displacement dx. So your first expression, you start the derivation from this point, you should keep remember this. Small amount of work done dw is fx vector dot dx vector. Fx vector is how much? The electrostatic force acting on this test charge plus Q due to source charge plus Q. So you can use the Coulomb's force formula. This distance is x, product of the charges is Q into Q, and proportionality constant is beta. So this is the force Fx. X means variable force acting on the test charge plus Q at the point A due to source charge plus Q. So by using Coulomb's force formula, we have written this. Fx is equal to beta capital Q into small q by x square. This is the Coulomb's force formula. Now you proceed for the derivation. First you write the small amount of work done due to dot product of force and displacement. Again you see the diagram. Source charge is positive, test charge is positive, so force is repulsive in this direction. Now you moving the charge here, so displacement is in this way. So angle between dx and fx vector is 180 degree. So here angle is written, theta is 180 degree. So dot product is taken as minus fx dx, because if you open it, fx dx cos 180, cos 180 is minus 1. Now just to remember, if you have taken negative source charge, then force will be attractive, so force will be in this direction, so theta will be 0, so here will be plus. So from the starting derivation, if you are taking positive source charge, minus sign in starting derivative, minus term will come. If you will take negative source charge, then plus sign will be start from initial derivation. Now proceed for positive source charge, starting will be minus. Now this is the value of fx, beta q by x square, integrating both these sides, constant term taken outside, and integration limiting value you keep remember here. What is the amount of work done? Total work done, let W. Initially work done was 0, so it is 0 to W. And initially x coordinate is infinite, and finally x coordinate is r. This is the initial coordinate and this is the final coordinate. So total work done by integration, that amount is W minus beta q and q. By using the principle of integration, 1 by x square integration is minus 1 by x, limiting value infinite to r. Total amount of work done is W here, minus beta q and q. Put the value minus 1 by r, minus minus is plus 1 by infinity. If you put minus sign here, this is 1 by r and this will be minus 1 by infinity. 1 by infinity is 0, so minus minus plus. So potential energy for bringing a test charge from infinite to the desired point is how much? Plus beta q by r. So final answer is plus if you are taking positive source charge. If you will take negative source charge, starting derivation will be plus, final derivation answer will be minus. So you should remember, if a positive source charge, while solving the problems, you should plus sign. For negative source charge, your answer should be minus sign. Now this is electric potential energy. Now we will proceed for electric potential. What is the formula of electric potential? U by Q, total amount of work done per unit charge. So that is U by Q. So small q is cancelled out. That means test charge is eliminated. Now the electric potential formula is plus beta q by r. Similarly, you also remember, for positive source charge, electric potential will be plus sign. For negative source charge, electric potential will be minus sign. This is very vital. While you are solving the problem, you should keep plus sign and minus sign. For positive source charge, sign is plus. For negative source charge, sign will be minus. This part we will discuss in the conclusion part. Now you have to discuss what answer comes. We have to go for the derivation. So this is the formula. V is equal to plus minus beta q by r. This is the formula of electric potential, and this is the formula of electric potential energy, plus or minus sign here also here. What is the physical significance of plus and minus? In calculation of potential, plus sign will be taken if it is a positive source charge. Minus sign will become for negative source charge. Similarly, in the calculation of electric potential energy, the significance of plus sign represent repulsive electric field, and the negative sign implies significance of attractive electric field. Again, you also remember, for solving the problem beta in vacuum SI system, you will represent 1 by 4 pi epsilon 0. In a CJ system, beta in vacuum will be 1. In general formula, we have written beta here. For SI system, you will put 1 by 4 pi epsilon 0. For CJ's unit, you will put 1. Now, second conclusion. just to see V plus minus beta Q by R. For positive source charge, I will write V proportional 1 by R. For negative source charge, I will write V proportional minus 1 by R. For both the cases, if you will increase the distance, you just V is inversely proportional to plus 1 by R. Here V is inversely proportional to minus 1 by R. If you will plot the graph V versus R, for positive source charge, graph will be like this. For negative source charge, graph will be like this. So how will you physical interpretation I will give? Now in case of positive source charge, with increasing distance, value decreases from positive value to 0. Infinite means finally it will be 0. Positive value changes to 0. But in case of negative source charge, finite negative value tends to 0. Positive to 0 means that is decreases. Negative to 0 means increases. So you should remember, for positive source charge with increasing distance, the electric potential decreases, usual behavior. But for negative source charge with increasing distance, electric potential increases. From formula you can also guess. If you do not follow the formula, just to draw the diagram, then you can easily explain how the electric potential decreases in case of positive source charge with increasing distance, how the electric potential increases in case of a negative source charge with increasing distance. This is the difference between discussion of electric potential with respect to distance for positive source charge and a negative source charge. Now we have to discuss how it depends upon the test charge. Your test charge is small q. You see the formula, there is no test charge. Actually in the derivation, small q is eliminated. That means there is no change in electric potential for positive source charge or negative source charge if you will increase or decrease the test charge. That means electric potential is independent of magnitude of test charge. As we have discussed, the electric field intensity is also independent of magnitude of the test charge. And V, you will plot the test charge, graph will be straight line parallel to the test charge axis. Now the last part, this formula is given for you. This is the amount of work done for moving a charged body from point 2 to point 1 in the given electric field. What will be formula? Beta capital Q into small q. That means source charge and test charge, and the coordinate of first point and the coordinate of second point. How I get this formula? You just see the derivation. Two coordinates are there. As here infinite coordinate represent 0. But if the two finite value, so the electric amount of work done in the electric field depends upon how much? The proportionality constant beta, that means medium. And two charges depends upon the magnitude of the two charges, and it depends upon the initial coordinate and the final coordinate of the test charge. Just to see the diagram, this is the source charge plus q. You are taking your test charge from plus q from A to B by two different paths, path number P and path number Q. If you will solve this formula for path number P, R1 reading, and you will put the R2 reading. R1 and R2 means the coordinate R1 from the plus Q and the coordinate R2 from the plus Q. If you will do the same work for path number Q, same answer will come. There is no change in coordinate of initial point and final point. That means the amount of work done only depends the coordinate of initial point and final point. If you are not changing the coordinate of initial and final point, you are just changing the path, there will no change in answer. That means work is independent of path. For this path, if work done is 10 joule, for this path work done will be also 10 joule. That means work done by the electrostatic force is a constant quantity. That means electrostatic force is a conservative force. While we discuss the property of electrostatic force, just to remember, we have discussed a property, the electrostatic force is a conservative force. Conservative force means work is independent of a path. Here you see, by using this formula, you can explain work is independent of path. Here this work is done by electrostatic force. So our conclusion is electrostatic force is a conservative force. So what we have discussed today, just we will go through it. First, to define what is electric potential energy and electric potential. Potential energy means some amount of work for moving a test charge from infinite to desired point. Similarly, what is electric potential? Some amount of work per unit test charge. If its unit is joule, its unit will be joule per coulomb, or you can say volt. And both are scalar quantity. Similarly, dimensionally there is no problem for you. Potential energy dimension is m1 L2 T to the power minus 2. And electric potential, while you calculating the dimension, use the formula W by Q. And W put m1 L2 T to the power minus 2. For charge you put A1 T1, then you can check it. Then we have to discuss what is electric potential difference. Potential difference means there is two fixed point is there inside the electric field. You just calculate the amount of work first, then you divide the charge Q. That means the amount of work done for moving a charge from one point to another point per unit charge. This represent electric potential difference. So in formula calculation you will write dW is equal to dW by Q. And using this formula we are defining a term electron volt. First to remember, this is not a potential, this is an energy. What this energy represents? Now this represents the amount of work required for moving an electron from one point to another point in the given electric field of a potential difference 1 volt. Again you also see the procedure how 1 electron volt is 1.6 into 10 to the power minus 19 joule. Very simple procedure is there, so you can easily calculate how 1 electron volt is 1.6 into 10 to the power minus 19 joule. Then we have discussed the general derivation of electric potential due to single isolated point charge. So general formula is plus minus 1 by 4 pi epsilon 0 Q by R for SI system. And positive sign is taken for positive source charge, negative sign will be taken for negative source charge. And we have also the different factors on which the electric potential depends. Then we will proceed for the electric potential for electric dipole in your next class. So just what we have discussed today, you just cross over it. Then in next class we will discuss how can you calculate the electric potential for the electric dipole, as we have discussed in electric field intensity. Thank you all.